All right, so in these problems, I'm determining the percent composition, and there are two different ways that I can do that. I can do it if I'm given mass, and I can do it by using the formula for a compound. So let's first do it if I'm given the mass. So number one says, what is the percent composition of oxygen in an aluminum oxide if the mass of aluminum is 2.70 grams and the mass of aluminum oxide, so the total mass, is 5.10. So I'm asking, what is the percent composition of oxygen, but I'm given just the mass of aluminum and the mass of aluminum oxide. Well, if I am just adding aluminum and oxygen together to give me aluminum oxide, well then to determine the mass of just oxygen, I need to subtract the mass of aluminum, 2.70, from the total mass, which is 5.1. So 5.1 minus 2.70, the mass of just oxygen is 2.40. So I'm going to put 2.40 up top, that's the mass of oxygen. I'm going to divide by the total mass, which is 5.10 grams. And then I'm going to multiply by 100%. Okay, so 2.40 divided by 5.10. Okay, that's 3 sig figs for each of these, by the way, 2.40 and 5.10. So when I get my answer, okay, unrounded, it is 47.059%. I want 3 sig figs. 2, 3. So this is going to be 47.1%. So again, I find the mass of what I'm concerned about. Either I'll be given it, or like in this case, I have to actually calculate the mass of oxygen. Then you divide by the total mass of the compound, and that multiplied then by 100%, and that will then give you the percent composition of oxygen in aluminum oxide. Okay? Well, if I'm not given the masses and instead just given the name of the compounds, I can also determine the percent of oxygen. So in this problem, I have aluminum hydroxide. Well, aluminum, I first need to figure out the formula. So aluminum is 3+, hydroxide is 1-. So the formula for this is going to be Al in parentheses OH3. Okay? So to determine the mass percent of oxygen, I'm going to put the molar mass of just oxygen up top. Well, the molar mass of oxygen is 15.999, but I have 3 of them, so multiply that by 3. So that gives me 47.997. Then I'm going to put that over the total molar mass of the compound. So I need to take aluminum, which is 26.982, add to that the molar mass of oxygen, 15.999 times 3, and then I'm going to add to that the molar mass of oxygen, 1.008, multiply that by 3, and the total molar mass I get is 78.003. I'm going to multiply this by 100%, okay, and I will get my answer. So I'm going to take 47.997, divide it by 78.003, then multiply by 100. It tells me to round to 2 decimal places, so unrounded it is this. So I want just 2 decimal places. So this will round to just 61.53%. So I can be given the mass, like I was in the first problem, and find the percent composition pretty easily. Or I could just be given the formula, and then I would use the molar masses to determine the percent composition of an element in that compound.